Hi students, welcome to my class. Dear students, today we are going to discuss the new lesson that is called as circle. See, these circle concepts we are discussed in the last year in the 9th standard briefly, and entire circles concepts we are discussed in the last year classes, and also from the 5th standard onwards and 4th standard onwards we are already learned from the circle. What is circle? What is the part of circles? We know already. So today we have to discuss some basic concepts of the circles, and related one theorem is there. So today we have to discuss that theorems. So let us start it. See, first one, we know already what is mean about circle. See, circles is one of the closed curvilinear figure. Closed curvilinear. Curvilinear means curved line. Curved line. The circles is this figure is bounded by a curvilinear line, and it is a closed figure that is called as circle, and also a collections of all points in a plane, that is called as also a circle. And then this circle is equidistant. This boundary is equidistant from the fixed point. That means from here to here, here to here, here to here. Where it have to write the line, but this point is equidistant from the boundary. That fixed point are called as center. That fixed point is called as center. And then radius. We can write the radius. See, the distance between the center of the circle and any point on a circle, boundary of the circle, that is, I will call it as P. That is, OP is what? The radius. OP was radius. Understood? What is the meaning of radius? The distance between the center of the circle to the any one point of a circle or boundary of a circle is called as radius. In a circle, how many radius can be drawn in one circle? So it is infinite number of radius can draw in a circle. We already know it. And also in a circle, all radius are equal. All radius are equal. That means OP how much? For example, 5 centimeter. If it is the radius is 5 centimeter OP, and then OQ is also becoming 5 centimeter. Are you understood? In the circle, the number of radius, infinite number of radius can draw in a circle, and every radius are equal to each other. Okay. The next one. This is the center of the circle. This is the boundary of the circle, and then this boundary. What we call this boundary? That is called as circumference. That is called as circumference of the circle. What is the meaning about circumference? Circumference means the length of the boundary of the circle. The length of the boundary of the circle, that is called as circumference, like a perimeter. In a linear boundary, linear figure, we call it as the boundary. Length of the boundary we call it as perimeter. In a curvilinear figure, we call it as circumference. Okay. Here, the circumference can be represented with the letter C. So we know that what is the formula of finding the circumference of circle? 2 pi r, or C is equal to pi d. Okay, keep in your mind these two formulas. So what is the circumference of a circle? C is equal to 2 pi r and r pi d. Both are same. When we are using this 2 pi r, when we are using the pi d. When the radius are given, you have to use this 2 pi r. When the diameter is given, C is equal to pi d. Both are same. Okay. So next, we know that pi value, it is equal to 22/7 or 3.14. Both are same. Okay. This is the constant. Next, student, diameter. What do you mean about diameter? Radius already learned it. Now diameter. What do you mean about diameter? Diameter is the line segment joining the any 2 points on a circumference of a circle, but that line is passing through the center of the circle. It passes through the center of the circle. See, this is the one point of the circle and also another point of the circle. I am joining these 2 points. This is A and this is B. I am joining A and B. It passes through the center of the circle. That length is called as diameter of a circle. In a circle, how many diameter can be drawn in a circle? It is also infinite number of diameter can be drawn in a circle. Okay. See, all the diameter are equal to each other in a circle. Every diameter is also equal in a circle. Okay. So next one, students. Yes, this is center of the circle, and what we call this one? Chord. This is called as chord. What do you mean about chord? Chord is a simple, very simple. The line segment is joining the any 2 points of a circumference of a circle. The line segment joining any 2 points of a circumference of a circle is called as chord. See, students, in a diameter and chord, what is the difference between the diameter and the chord? In a diameter, it is also like the joining between the 2 points of any 2 points of a circle, circumference of a circle, but it is passes through the center. In a chord, it is not need not to be passes through the center. If it is passes through the center, what it happen? It is a diameter and also a chord. It is also a chord, but it is a longest chord in a circle. Longest chord. Which is the longest chord in a circle? Diameter is the longest chord in a circle. Okay. So, and then see, this is what? Radius. Radius can be represented with the letter R. And this is what? This is also radius. This is O and this is AB. Okay. OB is also a radius and OA is also a radius. So the two radius, can you join? If you join the two radius, what it then become? It is called as diameter. So the diameter is twice of the radius. Correct? Diameter ಆಗಬೇಕಂದ್ರೆ radius ನ double ಎರಡರಷ್ಟು diameter ಇರುತ್ತೆ. Radius ನ ಎರಡರಷ್ಟು diameter ಇರುತ್ತೆ. Understood? Or radius is half of the diameter. Radius is half of the diameter. Diameter ಇನ ಅರ್ಧದಷ್ಟು ಇರುತ್ತೆ. Diameter for example 10 cm ಇದ್ರೆ radius 5 cm ಇರುತ್ತೆ. Radius 5 cm ಇದ್ರೆ diameter 10 cm. That's why the diameter is the twice of the radius and the radius is half of the diameter. Keep in your mind that is also. So next, student, chord. Are you understand the chord? So longest chord in a circle is what? Diameter. Next. Next one, student. Yes. I will cut it. This and this one. What is the part of the circle? What is the part of the circle? Do you know that? Yes. This is a arc. What do you mean about arc? Arc means the part of a circle. Nodi, ee circle ist part ana tagididini. So can you become a circle? No. When you are joining this and this part, if you are joining, then it making a circle. Until it will not making a circle. That's why this is a part of a circle. So the part of a circle are called as arc. See, this is a bigger arc. This is a smaller arc. That's why it is a major arc. This is a major arc and this is a minor arc. So smaller arc we call it as minor arc. Bigger arc is called as major arc. Okay. So next, student. See, this circle. This is center and this is a diameter. So what is this part of a circle? So this is the half of a circle, that is called as semicircle. So semicircle means half of a circles are called as a semicircle. So what is the circumference of a semicircle? It is equal to pi r. Because of circumference of a circle is equal to 2 pi r. Half means by 2. 2 get cancelled, what is the remaining here? Pi r. So that's why the circumference of a semicircle is pi r. Circumference of a circle is 2 pi r. Can you understand? So next, student. So this is a circle and this is a center and this is a chord. Okay. This is chord and this is what? Arc. And this area, what we call this area? We already learned in the 9th standard. What we call this area? Yes, segment of a circle. Segment of a circle. What do you mean about segment of a circle? So segment of a circle means the area is bounded by, the area is between one chord and an arc. A area is bounded by a chord and an arc. This area, this region is called as segment of a circle. Sir, this is chord and this is also what? Arc. What we call this area? This is also called as segment of a circle, but this is a major because of this chord. This area is bounded by a major arc. That's why we call it as major segment of a circle. Major segment of a circle. This is called as minor segment of a circle. Are you understood? So what do you mean about the segment of a circle? Very simple. The area is bounded by one chord and then arc. Chord and arc, in between this area we call it as segment of a circle. So next one. This is center. And so this is what? Radius. This is also radius. This is 2 radii and this is called arc. This region, this area we call it as what? Sector of a circle. Sector of a circle. What do you mean about sector of a circle? Very simple. See students, OA and this is B. OA and OB are the 2 radii. AB is a arc. The area is bounded by 2 radii and an arc. That area is called as sector of a circle, but this is a minor arc, that is called as minor sector of a circle. So this is also arc and this is also radii. These regions are called as, so what we call as, this is major sector of a circle. You understood? What do you mean about the sector of a circle and the segment of a circle? And last one. So this is circle and this center. This is also circle. This is also circle. See, what we call this type of the circles is called as concentric circle. What do you mean about concentric circle? Concentric circles means a circle having a same radius. See, this is C1, this is C2 and this is C3. Circle 1, circle 2, circle 3. All these circles having a same center but different radii. This radii is R1, this radii is R2, this radii is R3. Therefore, the circle having the same center but different radii, that is called as concentric. Centric means same circle, same center. That's why all circle having the same center and a different radii are called as concentric circles. Okay? Yes. This is the what? Major concepts of the circle. These concepts we already learned in the 9th standard. Already learned in the 9th standard. Okay. Next student, tangent of a circle. Come to the tangent of circles. See, what do you mean of tangent of circle? So this is a circle. Okay. So this is one. Sorry. Before going that, so this is circle and this is a line. Okay. So this line is no, it does not intersect or it does not touch the circle. So it only a line, it is a circle, that's it. So come to this case. Okay, see, this is one of the point of a circle. So this point is lies on a circle. So I am draw one of the line segment. This line segment, it touches it intersects the circle at only one point. The line segment, it intersects a circle at only one point. Then the line segment we call it as tangent of a circle. Tangent of a circle andre ಒಂದು ಸರ್ಕಲ್ ಅಲ್ಲಿ ಒಂದು ಸರ್ಕಲ್ ಅನ್ನ ಯಾವುದೋ ಒಂದು ಲೈನ್ ಸೆಗ್ಮೆಂಟ್ ಆ ಸರ್ಕಲ್ ಅನ್ನ ಟಚ್ ಮಾಡ್ತಾ ಇದೆ, ಇಂಟರ್ಸೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೆ. ಎಷ್ಟು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೆ ಅಂದ್ರೆ at least only one point, that is called as P ಅಂತ ತಗೋಣ. So this is AB ಅಂತ ತಗೋಣ. So see students, the AB lines is intersect the circle at the point, only one point, that is called as P. This AB line segment is touches the point B, therefore AB is a tangent in this line segment, or in this line is intersect the circle to the point P. this point P we call it as point of contact. Point of contact. Okay. See, a circle, the line segment is intersect a circle at only one point, that is called as tangent of a circle. That point is called as point of contact. Okay. So now students, take one circle. So how many tangent can draw in a circle? How many tangent can draw in a circle? One circle ಎಷ್ಟು tangent ಅನ್ನು draw ಮಾಡಬಹುದು? See, you can draw any kinds of line, but that lines it intersect a only one point. See, how many tangent? It is infinite number of tangent can draw in a circle. Okay students, see this circle, this is what center of the circle. See, I will draw here one of the tangent. This is also a tangent, and this is also tangent. Okay, and this is also tangent, and this is this line. Is it a tangent? No, it is not a tangent. Why? Because this line is intersect a circle at 2 points. So this point and this point, 2 points, these lines are intersecting a circle at the 2 points. Therefore, this is not a tangent. What about this line? So this is called as secant. What we call secant of a circle. See, what do you mean about secant of a circle? Very simple students. In any circle, the line segment it intersect a circle at a two distinct point. ಎರಡು ಡಿಸ್ಟಿಂಕ್ಟ್ ಪಾಯಿಂಟ್, ಒಂದು ಲೈನ್ ಒಂದು ಸರ್ಕಲ್ ಅನ್ನ ಎರಡು ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಇಂಟರ್ಸೆಕ್ಟ್ ಮಾಡ್ತಾ ಇದೆ. Therefore, this line we call it as secant. Understood? So then, how many secant can draw in a circle? This is also infinite number of secant can draw in a circle. ಎಷ್ಟು ಬೇಕಾದರೂ secant ಅನ್ನ ಡ್ರಾ ಮಾಡಬಹುದು, ಎಷ್ಟು ಬೇಕಾದರೂ tangent ಅನ್ನ ಡ್ರಾ ಮಾಡಬಹುದು. ಹಾಗಾದ್ರೆ ನೆಕ್ಸ್ಟ್ ಸ್ಟೂಡೆಂಟ್, in a circle, see, in a circle ABA only one point on a circle. So how many tangent can draw in a circle? It is infinite number of circle. This is a point of circle. And how many parallel tangent can draw in a circle? How many pair of tangent can draw in a circle at a one time? One time ಅಲ್ಲಿ ಎಷ್ಟು pair of tangent ಅನ್ನ ನಾವು ಒಂದು ಸರ್ಕಲ್ ಅಲ್ಲಿ ಡ್ರಾ ಮಾಡಬಹುದು ಅಂದ್ರೆ only one pair, that is two tangent. If you draw only two tangent at different points, see, this is one of the tangent and this is also tangent. This line is touches the point A, this line touches the point B. These two tangents are parallel to each other. When the two tangent can draw in a circle, it become parallel to each other at the same time. Okay, so next student, so these are the point tangent and the secant. Are you understood the point of what is mean about tangent and what do you mean about secant of a circle and the point of contact? What is the difference between the secant and tangent? In a tangent, a line segment it intersects only one point, but secant it intersects the two distinct point. That is the difference between the tangent and the secant. Okay? Yes. Shall we go to the next one? Yes. So that is theorem. Shall we go to the theorem number 1? In this chapter, students, only two theorems are there. Very very important two theorems. So among these two theorems, the first any one of the theorem they are given, definitely given in the examination. So be careful and learn properly. Okay. See, first, what is the theorem number 1? The tangent at any point of a circle is perpendicular to the radius through the point of the contact. See what you mean about this meaning of this statement. See, first of all I will draw one of the circle. In that circle, see the tangent at any point of a circle. ಯಾವುದಾದರೂ ಒಂದು ಪಾಯಿಂಟ್ ಇಂದ ಒಂದು ಸರ್ಕಲ್ ಗೆ ಟ್ಯಾಂಜೆಂಟ್ ಅನ್ನು ಡ್ರಾ ಮಾಡೋಣ. I will draw here. So this is what x, this is y. I will take it as x and y is a tangent of a circle, and this is p is a point of contact. Okay, p is a point of contact. See, the tangent at any point of a circle is this tangent is perpendicular to the radius. Perpendicular to the radius. How? Through the point of contact. See, point of contact in this is center of the circle. Point of contact ಇಂದ ನಾನು ಏನು ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಒಂದು ರೇಡಿಯಸ್ ಅನ್ನು ಡ್ರಾ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. This tangent is perpendicular to the radius through the point of contact, that is xy is perpendicular to OP. That one we have to prove it. What do we prove it? This tangent is always perpendicular to the radius of the circle through the point of contact. Suppose like this. So this is circle, this is tangent. So this is center of the circle. Okay, this is radius. So this radius, this tangent, is it perpendicular to each other? No. So how it become perpendicular? The radius it can draw in a point of circle, through the point of circle. Then it become perpendicular to each other. So that one we have to prove it. Okay. So what is the given? Very simple, students. O is a center of a circle. xy OP is a radius and xy is tangent of a circle. Okay. So next, student, to prove what you have to prove it, that is want to prove. So what is the prove it? The tangent of a circle is perpendicular to the radius through the point of the contact. That means xy is perpendicular to OP. xy is perpendicular to OP. This one we have to prove it. Okay. Next, small construction is there. What do you mean about construction? See, draw Q. See, take point Q on the tangent xy and join OQ. These OQ lines intersect the circle at the point A. See, take a point Q on the tangent xy and join OQ and it intersect the circle at A. So Q ಅನ್ನೋ ಪಾಯಿಂಟ್ ಅನ್ನು xy ಮೇಲೆ ಮಾರ್ಕ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀನಿ. So then I will join to OQ. This OQ line is intersect the circle at the point A. Yes. Next, proof. Very simple proof is there. See, students, here OP and OA. What are those? OP is equal to OA. Why? OP is equal to Y. OP is equal to OA. Why? Because of OP and OA are the radii of a circle. Is it right? Radii of a circle. That's why in a circle all radius are equal. That's why OP is equal to OA and OQ. See, this line OQ can be written as the sum of the OA and AQ. The sum of the OA and AQ, then it will get the OQ. Is it right? Therefore, OQ is equal to OA plus AQ. Can I write like this? OQ is equal to OA line segment and AQ line. So the sum of these two part of the lines can be written as OQ. Okay. So OA plus OQ, AQ. If you add means we can get the OQ. So it is indicated that see this OA and AQ, these two parts are less than the OQ. For example, see students, this is OQ. Okay, this is A. So this OA, this is the OA, and this is AQ. This line segment is AQ. Okay, so see students, OA and OQ we should compare it. OA and OQ should compare it. So OQ is greater than OA. Is it right? Or OA is less than OQ. This part is less than OQ, bigger part, and AQ is less than OQ. Both are smaller than the OQ. OA is smaller than less than OQ, and AQ is also smaller than OQ. That's why, see students, see this OA is less than OQ, and AQ is also less than OQ. Okay, see OA is less than OQ ಆದ್ಮೇಲೆ OA OQ ಗಿಂತ less than ಆದ್ಮೇಲೆ OP ನೂ ಕೂಡ see OP is also less than OQ because OA and OP are both are same. OA and OP both are same because of radii of a circle. That's why OA is less than OQ as well as OP is also less than OQ. Is it right? Yes. It is indicated that, see students, OQ is a longer side, largest side. Therefore, OQ is longest side of a side. And which is the smallest here? OA is the smallest. Sorry, OP is the smallest. OQ is a longest side, and OP is a shortest side of a circle. Okay, OP is a shortest side of a circle. Therefore, see when you are I will show now. So this is one of the line segment. This is one of the point above the line segment. See, when I am drawing the line from the point O to the line AB, see this line, these all lines, when is going to, this is O. So when you are going to left of the O or right of the O, point O, so this line is always greater than. So when you are drawing to right side of the circle, the line segment is longer than the previous line. So come to left side is also. So see, OP is one of the line. So when you are drawing this side, means left side of the point O, that lines are longest. Nodi, OP ಅನ್ನೋ ಲೈನ್ OP ಗಿಂತ ಆ ಕಡೆ ನೀವು ರೈಟ್ ಸೈಡ್ ನೀವು ಲೈನ್ ಅನ್ನು ಡ್ರಾ ಮಾಡ್ತಾ ಹೋಗೋದು ಲಾಂಗೆಸ್ಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಲೆಫ್ಟ್ ಸೈಡ್ ಗೆ ಮಾಡ್ತಾ ಬಂದ್ರೂ ಕೂಡ ಏನಾಗ್ತಾ ಹೋಗುತ್ತೆ, ಲಾಂಗೆಸ್ಟ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Is it right? So when you are drawing both right side and the left side of the OP, that all line segments are longest than the OP. That's why OP is a what? Smallest side. See, this OP is the smallest or shortest. OP is only smallest. In among these, the remaining sides is greater than the OP. That's why OP is the smallest side. In that concept, I am using here. So OP is a shortest side of a circle. Therefore, this shortest side is always perpendicular to the tangent. Okay. Therefore, XY is perpendicular to OP. That's it. Are you understood? So like this you have to prove it. Very simple students. First write down the given to prove, and construction we already know it, and proof very simple. OP is equal to OA, have to take it because of radii of a circle. This OQ can be written as OA plus AQ. This is meaning that OA is less than OQ and AQ is also less than OQ. And also when your OA is less than OQ and OP is also less than OQ, because of OA and OP are equal because of radii of circle. See, OQ is a longest in the circle side and OP is the shortest side of the circle. So but OP is always perpendicular to the, when the which side is the shortest side of the circle, that side is always perpendicular to the given line segment, that is called as tangent. Understood? Yes. So this is very important theorem. Okay students, so next I will go to the exercise, first exercise in this chapter 4.1. In this exercise, first main and second main. First question, how many tangent can draw in a circle? That is infinite number of tangent can draw in a circle. That is the first question. In the second questions, there are some fill in the blanks are there. You can do it in your home. So I will show you the third question only. And fourth question is the only one question is there. That is draw a circle and draw the tangent and secant. Very simple. So but I am showing only third questions is there. See, a tangent PQ. This question is depend upon the theorem number 1. Okay. A tangent PQ at a point P of a circle of radius 5 cm meets the line through the center O at a point Q, so that OQ is equal to 12 cm. Length PQ is, see, this is one of the circle. See, this is the O is the center of the circle and this is one of the tangent. So PQ is a tangent. Okay, this PQ is a tangent. O is the center of the circle. See, the tangent PQ. See, PQ is a tangent. P is a point of contact, and then P of a circle of a radius 5 cm. This is the radius. OP is the radius. This is 5 cm. And then the length of the tangent, how much centimeter is there? OQ is 12 cm. OQ is 12 cm. We have to calculate the length of the tangent. We don't know, that is called as x. I am taking care x. So option number 1, 12 cm, 30 cm, 8.5 cm or root 19 cm, which is correct. We have to find it. Very simple students. This radius is perpendicular to the tangent of the circle. Now only I will go in the theorem number 1. That's why this is become a 90 degree and OPQ is become a right angle triangle. Yes, PQ is perpendicular to OP because of theorem number 1. Okay, theorem number 1. That's why. Then in triangle PQ, OPQ, angle P is equal to how much degree? 90 degree. I am using the Pythagoras theorem. See, OQ square is equal to OP square plus of PQ square. This is the what? Pythagoras theorem. Now students, OQ square, what is the meaning? Length of OQ? 12 cm. That is called 12 square. OP means 5 square plus PQ square as it is right now. We have to calculate the PQ only, otherwise we have to put question mark. Now 12 square means 144. It is equal to 25 plus of PQ square. Now we can send 25 to the LHS. It becomes minus 25. Therefore PQ square is equal to 144 minus of 25. Therefore PQ square is equal to what? PQ square is equal to 119. See, 144 minus of 25. 14 minus of 5 is 9. Here 3 minus of 2 is 1. Here 1 is 1 as it is written. Therefore PQ, if we want PQ, square root of 90 centimeter. This is the length of the PQ. So option number is D is correct. Understand students? So like this you have to solve it in this these problems. Okay. So like these problems, it is depend upon the theorem number 1. You have to understand properly and draw a figure, and then we have to find it the answers. Understood? Yes. Yes students, in the next classes we have to discuss the one more concept is there. So one more theorem is there. So that theorem we have to discuss in the next classes. Okay. Thank you.